Started with our lesson on 1.2, which is solving multi-step equations. In 1.1, we solved one-step equations, so now we're going to get into multi-step. All right, well, there's 4 warm-ups here for you, so why don't you go ahead and tackle the first 2. Pause the video. Same game plan here. I want you doing as much of this as you can on your own, and then obviously you can watch me go through it. But try 1 and 2, and then play the video. Okay, so on number 1 here, we're simplifying expressions. We're not solving equations. And we have a negative and then parentheses. So what do we need to do to get rid of those parentheses? Well, the first set of parentheses don't really matter here at all. They, really aren't significant. But this negative there is saying it's the opposite of everything in here. So what property we use? We distribute, the distributive property. So the opposite of negative 2x squared is positive 2x squared. The opposite of positive 3x is negative 3x. In other words, we're multiplying negative 2x squared by negative 1, which makes it positive, and a positive 3x by a negative, which makes it negative. And then we look for any like terms that we might have. And remember, like terms are terms that have the same variable or variables to the same power. So they have the same exponent. And you can see that we have a term here, 2x squared, and another term that has an x squared. So if you wanted to, you could really circle these, or mark them in red, I guess, and then combine them together. We also have another pair, and I could do these in purple. Whoops, whoa. A negative 6x to the first power, and a negative 3x to the first power. And then what do I get when I put those all together? Well, 2x squared and 2x squared makes 4x squared. And negative 6x and negative 3x makes negative 9x. Remember, we're combining. We're not multiplying. Okay. Would it have been okay to put my answer as negative 9x plus 4x squared? Absolutely. Doesn't matter which term leads in this case. You just want to make sure you have the right sign. So you won't want to say, negative 4x squared plus 9x. That would not be correct. Okay, try this one. On this one, we're distributing a positive 1 there. So basically, we can just get rid of the parentheses. Combine your like terms. 2h squared and 2h squared make 4h squared. 5z and 9z make 14z. Okay, 3 and 4. Determine whether the given number is a solution to the equation. So basically, what we need to do here is plug in x equals 2, or 2 in for x here, and see if it balances. And let's see if that does happen. So give those a try. Okay, so I'm back. So obviously, I'm plugging in. So I'm using parentheses when I plug in. Order of operations says we do the multiplication first. 6 times 2 is 12, plus 1 is 13. So we have 13 on the left side. On the right side, we multiply again first. 14 minus 1 gets us 13 as well. 13 equals 13. Go ahead and say it. Check, check. Yes, check, check. It works. Okay, and then you would do the same here, plugging in the positive 3, excuse me. On the left side, again, careful, multiplication before subtraction. So PEMDAS, so 4 times 3 is 12. So we have 5 minus 12. What is 5 minus 12? It's negative 7. And by the way, notice how I'm working down my page. That's how I want to see your work when you're doing this. Much easier than working horizontally. Don't want to see that. So, okay, on the right side here, PEMDAS. So again, there's no parentheses or grouping symbols to worry about. These parentheses aren't really holding more than one term. So exponents. So 3 squared would be 9. So we would have 2 times 9 plus 3, which is 18 plus 3, which is 21. Does that equal negative 7? Afraid not. Okay. All right, here's a cool little exploration. Obviously, it says work with a partner. You may be able to try and do that if you want to give someone a call or FaceTime someone or whatever. If not, you can try it by yourself or grab someone in your house. The sum S of the angle measures of a polygon with n number of sides can be found by using the formula S, remember that's the sum of the angle measures, equals 180 times the quantity n, number of sides, minus 2. Write and solve an equation to find each value of x. Then find the angle measures of any one polygon. So you don't have to pick and do all three of these. If you want to, you can. That'd be cool, but you don't have to. So go ahead, pick one. Again, first you're going to want to use this formula based on the number of sides to figure out what the sum of the angles are, and then maybe use this information. Maybe I should do one of these with you guys, and then you can pick between B and C. That might be a good idea. Let's do that. So on this one, okay, 1, 2, 3 sides. Oh yeah, it's a triangle. So you probably already know we would plug in 3 for the n, and 3 minus 2 is 1. Grouping symbol, do that first. 180 times 1 is 180. So we know that the total sum of those three angles is 180. Well, how would we write an equation for that? Well, I know that this angle is 30, this one's 9x, this one is 30 plus x. If I add those three together, they equal 180. So 30 plus x plus 9x equals 180. And then I would just basically solve for x. So how would I do that first? On the left side, I'm going to combine like terms, right? X and 9x makes 10x. 30 and 30 makes 60. I then would subtract 60 from both sides, right? Because I want to get the term that has the variable by itself. So if I do that, I get 180 minus 60 is 120. Now I want 1x. I want to know what x is. That means 1x, not what 10x is. 10x equals 120, so how could I do that? Divide both sides by 10, and I get 12. Now I still haven't answered the question. I figured out what x was, but I haven't answered the question of find the angle measures of any one polygon. Well, if x is 12, then isn't this angle up here going to be 30 plus 12, which is 42? And this one is going to be 9 times 12, which is 108. This one we know is just 30. So 30 plus 42 and 108 are the three angle measures. How do we check to make sure that that's reasonable? Well, we know it should add up to 180, and guess what? Those three numbers add up to 180. Okay, try B or C. All right, well, I'm going to uncover here. Again, it's a triangle, so we know it's going to be 180. So hopefully you did 50 plus x plus 10 plus x plus 20 in any order. Doesn't have to be in that order. You get 180. Combine your like terms. X and x make 2x. 50 and 10 and 20 make 80. Subtract your 80 from both sides. Divide by 2, and x equals 50. And once I know that that's 50, I know that's 60. And then that one is 70. Add them all up, they equal 180. Okay, think about this one. This one's gonna be a little different. Some of the angles is not, angle measures is not gonna be 180 because this is what we call a quadrilateral, a four-sided polygon. And if you plug into the formula, 4 minus 2 is 2, and so 180 times 2 is 360. So these angle measures add up to 360, and you can see how they went through that. So hopefully you got those correct. All right, let's move on. Okay, so our core concept there is, okay, how do we go about solving multi-step equations? And it says here, to solve a multi-step equation, simplify each side of the equation if necessary. Then use inverse operations to isolate the variable. And isn't that what we just did back here? Like from this step right here, or this step right here, or this step right here? Didn't we combine like terms and then move to isolate our variable? So we've already done it. So let's look at these here. Is there anything that we can do to combine like terms on the left side? No, there's two terms here, 2.5x and negative 13, and neither of those, they're not like terms. One has an x, one doesn't. What about the right side? Well, there's only one term. How can we simplify that? Of course we can. So what's our next step going to be? We want to isolate this term that has our variable in it. So what would we do? That means this negative 13's got to go away. So what do we do to get that off that side? We add 13 to both sides. 2 plus 13 is 15. Now I want to know what x is, not 2.5 of x. So what do we do? Divide both sides by 2.5. And you can probably do that mentally. If you know 2.5 is half of 5, and 5 goes into 15, how many times? 3. 2.5 is going to go in 6 times. Okay, and now we're going to check it. How do we check? Right, you plug back in. So should have a 6 in there for the 2.5, And if you multiply 2.5 times 6, you get 15. And 15 minus 13 is 2. And that's what we have on the other side. Check, check. Okay, what about the next one? Go ahead and try it. Okay, this one we do have like terms, right? So again, you may want to consider circling your like terms. So we have 9x, which is positive 9x. Remember, if there's no sign in front of it, we know it's positive. This is kind of making a little bit of a mess out of this, but you get the picture. And negative 6x, those are going to make 3x. We want to get this term by itself. This one's got to go. How do we get this off? We subtract 15 from both sides, golden rule of equations. And negative 12 and negative 15 makes negative 27. Again, we want to get x, so we divide both sides by 3 or multiply by 1/3, and you get negative 9. Go ahead and plug it in and check it. 9 times negative 9 is negative 81. Negative 6 times negative 9 is positive 54. And notice that if you combine 54 and 15, those are two positives. Again, it's all addition, so you can do any order you want, commutative property. That's 69, and 69 and negative 81 make a negative 12. Check, check. Okay. So go ahead and try these, and then we'll work through these. So on this one, you do have like terms, so simplify each side separately. Hopefully you got negative 12x. We're going to isolate that variable terms. That means we're going to subtract 12 from both sides. That gets us a 6. Divide by negative 12. And 6 divided by negative 12 is negative 1/2. And when you check it, you plug back in. And negative 2 times negative 1/2 is 1. Negative 10 times negative 1/2 is positive 5. And we have the plus 12. Does all that add up to 18? Gosh, I sure hope so. I sure hope so. Yes, I did get the magic number. Check, check. Okay, let's go up here and do this one next. All right, don't get freaked out just because there's a fraction. Fractions are our friends. So we want to get this term that's got our variable isolated. There's nothing to simplify on either side separately. Now we need to move things to get that variable term isolated. So yeah, you're going to add 11. And when you add 11 to both sides, that would cancel, right? And that would leave us with a negative 10 on each side, on the left side, excuse me, and a 1/2 c on the right side. Now I don't want half a c, I want to get a full c, 1c. So what would you multiply a half by? The reciprocal, or the multiplicative inverse, which would be 2. And when I do that, this is like 2 over 1. 2's cancel, I'm left with positive c. And over here, 2 times negative 10 is negative 20. Okay, I didn't check this one, but you can see if you plugged in 1/2 times negative 20, that would get you negative 10. Negative 10 and negative 11 combined together gets you negative 21. Okay, next one. We need to simplify each side. Well, we got to get rid of those parentheses, right? That's part of simplifying. So we would need to do what operation, or what property? Use what property? Distributive property. So we would distribute, right? 2 and then negative 2x plus 3. Do we have any like terms on the left side to combine? Yeah, the 2 and the positive 3. That will make 5. Okay, now anything else we can simplify each side separately? No? Okay, let's get that variable term isolated. Means the 5's got to go. So combine it with a negative 5 to both sides, right? And if I do that, negative 8 and negative 5 make negative 13. Okay, divide by negative 2, and we end up getting 13/2. And if you want to put it at 6.5, knock yourself out. No need to. Improper fractions are totally fine in algebra AB as long as they're in reduced form, simplest form. So you wouldn't want to leave like 26 over 4, but 13 over 2 is fine. And if you plug it in to check it, you would see that it checks. Remember, 1 is the same as 2 over 2. So 2 over 2 minus 13 over 2 would be negative 11 over 2. In multiplication, that numerator 2 over 1 times that 2 in the denominator would cancel, and you'd be left with negative 11 plus 3, which is negative 8. Check, check. Okay, try this one, distribute this one. just go through this quickly. Combine your like terms. Isolate your variable. Check. Plug it in. Yay, it works. Okay. Again, I hope you're really working through these on your own and then watching me do it. And if you make a mistake, you can learn from that mistake. Totally important. Okay. All right, here's two more. So go ahead and try these. All right, I'm back. So obviously we're going to have to distribute first to simplify that left side. So hopefully you got negative 8m minus 20. So the negative 4 gets multiplied here and gets multiplied here. You may have learned this is kind of shooting arrows over a wall. And then we still have the negative 3m. Don't forget that. Equals 35. Combine your like terms. So negative 3m, negative 8m make negative 11m. We still have that minus 20, and we still have the 35. Hopefully next thing, isolate the variable term. So get rid of this. How do we make that become 0? By adding 20 to both sides. And so you hopefully get 55 over there. You see 11 and 55, and you smile. You don't have to deal with any fractions. Divide both sides by negative 11, and you get negative 5. Plug back to the original to check it. That's 2 times negative 5 is negative 10, plus 5 is negative 5, right? Times negative 4 is positive 20. 3 times negative 5 is negative 15. Oh, I'm sorry. Negative 3 times negative 5 is positive 15. So I got 20, right? And positive 15 makes 35. Check, check. Okay, try the next one. Okay, here we did have distribution twice. So hopefully you got 15, negative 5x, positive 6, negative 2x, and equals the 14. Two sets of like terms here. Did you catch them both? Hopefully. 15 and 6, 21. Negative 5x, negative 2x make negative 7x. Isolate that variable. Subtract 21 from both sides. And then divide by negative 7. And you get 1. 3 minus 1 is 2. So 5 times 2 is 10. 3 minus 1 is 2 times 2 is 4. 10 plus 4 equals 14. All right. Again, remember word problems. Use those techniques we talked about in 1.1. Go to your happy place. Stay calm. Or, hello, Mr. and Ms. Word Problem. I'm going to solve you now. Okay, it's word problem. Hello, Mr. and Ms. Word Problem. I'm going to solve you now. I smiled. I feel better about it. I know I can do this. And you'll build up, as you get more of these correct, you're going to build up confidence and you'll be all good. No anxiety. Use the table to find the number of miles X you need to bike on Friday so that the mean number of miles biked per day is 5. Okay, so I have to go through and think about this. Okay, I've got this chart over here, and it's told me exactly how many miles except for Friday. And I know that I have to get the mean. Oh yeah, that means the average. So for that, I have to add up all of the data values, in which case it would be 5, and I want that to have an average of 5. Okay, so how would I do that? Okay, well I know 3.5 plus 5.5 plus 5, that's going to get me 14, right? So X is the number of miles on Friday, right? I'm going to assign and define a variable. And then my equation is basically to add all of them up, and it has to equal 25. Hopefully you saw why that would be. There is another way you could have written this out, and that would have been to have all of this written out, have it divided by 5, and that would equal 5, right? Because that would be all the data values divided by the number of values, there's 5 values, equals what we need the mean to be, which is 5. But this is another way of setting it up too. If I set it up this way, combine your like terms, which would be that, and that, to 14. Get that x by itself by subtracting 14 from both sides, and you get 11. So your answer would be 11 miles. No naked numbers here. Okay. What's great about doing these video lessons, at least, I know COVID's not great, but at least, not great to say the least, obviously. but is at least you can pause the video and you can watch something again. You can go at your own speed, all that. It's great. Okay, here's a formula you do not need to memorize or know. Don't worry about that. We're just giving it to you. So the formula D equals 1/2 N plus 26 relates the nozzle pressure, N, in pounds per square inch of a fire hose and the maximum horizontal distance the water reaches, D, in feet. How much pressure is needed to reach a fire 50 feet away? Okay, so unfortunately, this, you can see, very important in California with the number of wildfires that we're suffering, especially in recent years. Okay, so you can see as a firefighter, this would be important to know. So you would want to know, like for the truck, like how much pressure would it need to have? Okay, so we have the formula with two variables here. Well, we know we're going to have to fill one of those in. And which one are we going to fill in? It says how much pressure, so we're solving for the pressure, and that was N, is needed to reach a fire 50 feet away. 50 feet is our D. Right. So you're basically going to plug in 50 for D and solve for N. So hopefully you subtracted 26 from both sides. You've got 24. And then we don't want half N. We want a full N. So hopefully you multiply both sides by 2. And the answer would be 48 what? 48, what's the label? Pounds per square inch. So pounds per square inches. Okay. Okay, your school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costume and props. After paying back the loan, the club has a profit of $100. How many people attended the play? Okay, so what's unknown? We want to assign and define a variable. The number of people. I decided to use X for this. Okay, and we know the club has a profit, right? And they had to borrow $400, okay? So think about how you would set that up and try and write an equation for that. And it's $4 per person, and a person is X. So what I did was, I know that 4X represents the total amount of money they've taken in. And if I subtract $400 to pay back the borrowed money, I'm going to have $100 left in profit. So one way of setting this up would be 4x minus 400 equals 100. Okay. You also could have done 4x equals 400 plus 100, saying, okay, well, I know I've got the 400 that I had to pay back and another 100, so that means I must have sold $500 or raised $500 by selling tickets. That would have been fine too. Because notice what's going to be happening next in our next step. We're going to add 400 to both sides, and then we would have had that 4x equals 500. Okay. And then obviously, hopefully you divide it by 4, and you got 125. So the answer would be 125 what's? People. Yes. Okay, and our last one. You have 96 feet of fencing to enclose a rectangular pen for your dog. To provide sufficient running space for your dog to exercise, the pen should be 3 times as long as it is wide. Find the dimensions of the pen. Okay. So 96 feet of fencing. That's perimeter, isn't it? 96 feet of fencing. And you notice I'm using one of those problem-solving strategies of drawing a diagram. But in order to kind of label the sides of my diagram, I need to have a variable. And the perimeter formula is 2L plus 2W, but I don't want to have 2 different variables. We don't know how to solve those types of equations yet. So let's think about this. We know that the pen should be 3 times as long as it is wide. So let's say I decided to make X the width, okay? Then that means that this would be the width. Remember, width in a rectangle is always the shortest side. Even if I rotated the rectangle by like turning my computer 90 degrees, these would still be the widths. Width is always the smallest side, no matter what way a rectangle is oriented. So that's X. This one, also X. What would the length be? If the length is 3 times as long as it is wide, 3 times whatever the width was, which is X. So 3X and 3X. And so now for the perimeter, you could either add up all the way around, right? And we know that that's got to be 96. Or you could go 2 times the length plus 2 times the width. So different ways you could set it up. So 96 went in for the P. I did 2 times the length, which we said was 3x, plus 2 times the width, which we said was x. Simplify this side, right? So that became 6x plus 2x, which is 8x. Get x by itself by dividing, and you get 12. So what are the dimensions of the pen? If x is 12, that's our width, right? What's our length going to be? 3 times 12, which is 36. And notice 36 and 36 is 72. 12 and 12 is 24. And if you add those together, 72 and 24, you get 96. All right, that does it for 1.2. Remember, you can always go back and rewatch it or pause. Make good use of the other resources you have available to you on Big Ideas. And I hope you got it.